In this video we are discussing cross-origin resource sharing, or CORS in short. So let's get started. Every standard browser enforces the same origin policy, which means a client or JavaScript-based app hosted in a server, say, phys.com, will be restricted from accessing data from another server, say, buzz.com, since the origins are not matching, where origin is a combination of protocol, domain and port. If any of these changes, the same origin restrictions automatically kicks in. On the screen here are a few examples where same origin policy restricts cross-origin data access. In the first case, there is a change in domain. In second, there is change in terms of subdomain, even that is not allowed. In the third case, there is a change in the port. And finally, for the last one, the protocol or the URL scheme change won't allow us to access data. The same origin policy is a critical security mechanism that restricts how a document or script loaded from one origin can interact with a resource from another origin. It helps isolate potentially malicious documents, reducing possible attack vectors. But the important point to note here is that the out-of-box availability of same origin policy in browsers doesn't mean that our servers are completely protected from cross-site request forgery, so it would be better to take reasonable precautions against such things. If needed, we can discuss that in a separate video. CORS provide a legitimate workaround against the limitations imposed by same origin policy and enables web clients to make HTTP requests to servers hosted on different origins. The cross-origin resource sharing standard works by adding new HTTP headers that help server describe which origins are permitted to read that information from a web browser. The specification mandates that browsers pre-flight the request, soliciting supported methods from the server with the HTTP options request method, and then upon approval from the server, sending the actual request. Servers can also inform clients whether credentials such as cookies and HTTP authentication should be sent with requests. So going back to our previous example of phys.com trying to access data from buzz.com. What JavaScript code in phys.com does is, with the help of the browser, it first sends a CORS pre-flight options request. Then the buzz.com server responds back with some additional HTTP headers, and only if the pre-flight is a success then the actual call for data is made by phys.com to buzz.com. Most common header to be set is access control allow origin. The value can be either the allowed origin, in this case phys.com, or can even be star, which means all origins are accepted. Not all calls need to have a pre-flight call. There are few exceptions where the calls don't need a pre-flight. Such calls are called simple calls. This is decided by the browsers based on a predefined criteria which is available in the link in the description.
CORS failures result in errors, but for security reasons, specifics about the error are not available to JavaScript. All the code knows is that an error occurred. The only way to determine what specifically went wrong is to look at the browser's console for details. That is all about CORS and its implications in JavaScript. See you in another video.